6, let's talk about probability. So what is probability? Probability is this area under the curve, this shaded portion. So on 5A it says traffic, the number of cars that pass through one intersection during a specific hour of the day is normally distributed. So I'm still on normal distribution here. And it gives me a mean. So I'm going to go change my mean value. This is in mean, comma, standard deviation. So my mean is 1,210. That's the average number of cars. And the standard deviation would be 220. That just means if you add 220 or subtract 220, you'd have 68% of the data. 68% of the time, you'd have a value between 1210 plus 220 and 1210 minus 220. Okay, so we want to know what's the probability of having between 1,000 and 1,420 cars. Well, that is simply, let me align my data here. That is simply, you put 1,000 here. What's the probability between having 1,000 and 1,420 cars? Since cars is the mean, you can plug it in as the min and the max. And it's saying what's the probability? It's this amount of area. Whatever the area is of all of this area shaded is the answer, which we're told is right there. It's approximately 66% of the data. So this is approximately or I don't have to do the approximately symbol after doing that. 66% is the probability. So the way you would actually write that is P of 1,000 probability of the random variable x being between 1,000 and 1,420 is, now I would do the approximately symbol, 6.66 is how you would actually write that out. So what's the function that occurs here? Well, if you wanted to, you could say n1 is this normal distribution. You could write all this out, but since I said n1 equals, I could just say n1.cdf, which stands for the cumulative density function, and I could put my values in here, 1,000, comma, 1,420, and you would see that that gives us that same value as well. That would be the math that you would type in there if you wanted to solve it that way. So just really quickly, I'm going to add this picture in because I think it can be helpful to see it. It's just really large, so let's shrink it down quite a bit. There you go. And let's look at part B. It says the number of cars. Okay, so the same situation. We want to know what's the probability that x is less than 950. That means 950 is the largest amount of number. So I'm now going to move 950 over here to the right side, and there's no minimum, so I'll just leave it like that. And over here, if you were going to type this in, you can't have a negative amount of cars, so I'll put a 0. If you were going to actually type it in the calculator, you'd have to do it like this, 0, comma, up to 950 cars. And you can see that, again, this is the same number. The probability of having 950 cars or less drive through the intersection looks like it's just below 12%. So let's go ahead and add this picture in there. Here, the probability of having less than 950 vehicles drive through that intersection is approximately, I'm going to say 11, I'll just use their decimal, 0.1186. Now I want you to find the probability, given the situation, that the number of flowers is less than 30.